if I'll just jump in here for a second, guys, and thank you everyone again for joining us, just as Syria has said. And I'll just advance the slide here. And that clip art tool that everyone just had a chance to play with, if you would like to click on it again, the very bottom icon in your toolboard strip, and select a shape and drop it on the map of Ontario to indicate where you're joining us from tonight. And you can also click on your text tool if you feel adventurous, and that is the capital letter A that you'll see on your tool strip, and click anywhere on the whiteboard and you can type in the name of the town or city that you're joining us from. Oops, I accidentally moved somebody's star over there. Very, very cool. We're very concentrated in southern Ontario, but I must ask, is there really someone on Manitoulin Island joining us? You can type in the chat as well if you want to. Sue, are you on Manitoulin Island? Wow. No wonder you've got connectivity issues. My parents live not too far down the peninsula from you, and it's a lovely, lovely place that you're at. So wow, this is a new thing. This is wonderful. Thank you so much. Okay, and look, we've got a whole bunch of other places in there. All right, that's fantastic. Oh, Claudia, your text box isn't letting you write. Okay, I don't know if you heard what I'd said earlier. If you hold your mouse down on the title bar of your chat box and pull that chat box off to the left or the right, that will unpin it from your interface, and hopefully that will reactivate your text box for you. Oh, and you've got someone else with you, Sue, and someone in Dryden. Is that what we've got way over there in Western Ontario?
Yes, that's correct.
Oh, that's you, Melanie. Oh, fantastic. Okay, well, thank you everyone for sharing that information. That gives us a really nice visual demographic of what Ontario teachers were serving with these sessions. And I will now pass the microphone over to Mary Kay. And if you have any further technical issues, just let me know in the chat, and I'll address them as we go along. Thank you.
Great. So could I just get a, well, first of all, welcome. And can I get a thumbs up if you can hear me? No problem. I'm going back and forth between two mics, and I want to get the best one. Thumbs up, okay. Seems good. All right. So, teaching number sense enumeration through problem solving. I'm going to start by putting up 3 different phrases. And I'd like to have you think about whether or not they are the same or whether they are different. And maybe you could respond in the chat or grab the mic and talk about them. But what would these sound like or look like in a classroom? Teaching about problem solving, teaching for problem solving, and teaching through problem solving.
Okay, while people post their comments on that, Mary Kay, you know what? I think your first microphone or the other one you're using does have better sound. If you don't mind swapping back again, that would be great.
I've swapped now. Is this better? This is swapped.
Yes, that's way, way, way better. Perfect. Thank you.
Okay. Awesome. Thanks, everyone. Okay, I like that comment, Claudia. They're different but all necessary. Okay. Don't be shy. Someone grab the mic. Okay, I'll go through what I think they are. Teaching about problem solving is something we were maybe doing a few years ago, and it's when we would have maybe a mini lesson or a full lesson on all the different strategies. So I might do a lesson on act it out, or I might use do another lesson on make a table or those. So I see that as being teaching about problem solving. Yeah, the old puddle questions. The next thing is teaching for problem solving, and this is what I used to do up until a few years ago. And I think this is really how textbooks are set up these days. So teaching for problem solving meant that I would teach, or I thought I would teach the students the algorithms or the way to do the calculation part of the math. And then towards the end of the unit, I would see if they could apply it and give them the traditional word problem or kind of culminating project at the end. So I would teach all my lessons to see if they could apply them at the end of the unit. And I see that as being teaching for problem solving. But that is fundamentally different than teaching through problem solving. And teaching through problem solving is really what I want to get into today and give you some planning prompts to help you make sure that you are teaching through problem solving. Because that's what all the research is telling us. That is what develops students' flexible and long-term understanding of the math concepts. And so it's really teaching for problem solving on its head. I don't think I'm going to say too much more about it now because we'll build our understanding of that as we go. So I've already seen some of you start to address this kind of idea in the chat, but why should we teach math through problem solving, where we just give students the problem up front as opposed to give them the skills and give it at the end? Oh, I like that. Different answers. They're relating to their experience. Absolutely. I don't want to rush your thinking. Differentiation. Absolutely. Can you expand on that, Sarah? Diane, nice. It's really the assessment for learning, right? We can see what they do know or what they don't know. Risk-taking, absolutely. The thinking, deeper understanding. Okay, I'm thinking I don't need to do this session because you got it all. Awesome. Awesome. Perfect. So the whole idea that it's differentiated, that it allows students multiple entry points and also multiple exit points. It's real life. It allows for a deeper understanding and a more long-term understanding. Absolutely. Another reason we should teach through problem solving, it's because it's what that book with the blue M on the front, or I guess the white M in the blue box, calls on us to do. This is right out of the curriculum, and it is telling us that teaching through problem solving is really the high leverage strategy for math instruction. So I'll just give you a second to read that. Any reaction to that? Thumbs up if you're in agreement. Awesome, awesome, awesome. So we're going to talk about teaching through problem solving for sure, and I chose the strand Number Sense Numeration. Just because I had to pick one, so I picked the one that seemed to be first. This is the strand in a nutshell. Most grades have 3 overall expectations. If you teach grade 4 and 5 and feel that you do more work than your other colleagues, you're right. Grades 4 and 5 actually have 4 overall expectations for the Number Sense Numeration strand. But you'll see that counting starts in grade 1 and then ends in grade 5. And proportional reasoning starts in grade 4 and goes all the way through 8. So intermediates don't practice their counting, and the primary doesn't start to explore proportional reasoning at all. So that's just a brief overview of this strand. Quantity, how much, the how muchness of a number has to be addressed in every grade. The operational sense of a number has to, or a set of numbers, I guess, has to be addressed in every grade. as well. So teaching through problem solving, how many of you are familiar with these 3 words, or your board may use 3 different words? I know that sometimes the mind's on is called activation, action is do it, and then consolidation. That's the only phrase I've heard for that part of the lesson. Does anybody call that anything else? Just watching the chat. I know some of you had microphones working a minute ago. Shy people. So these are the labels that we use. Oh, application. It could be application, although I think the application comes in the action part for sure. These are what we call them in my board, upper grand. And then the ratio beside that is the timing. And so actually this is a scale model. Oh, your next, oh, Louise, that's not good. They're all free. This is a scale model of what your math class would be. So our board tends to have 50-minute math classes. So that would mean that the minds on would only be 5 minutes, and the action would be 15 minutes, and then the consolidation of a math lesson is 30 minutes. And what we were finding as we started teaching through problem solving using this lesson structure, more typically teachers were doing about a 15-minute minds on, maybe a 30-minute action, and then a 5-minute consolidation. And all the research is saying it's in the consolidation phase of the lesson that the learning really happens. So we really want to encourage teachers to teach using this kind of ratio or proportion, where minds on 5 minutes-ish, and then 15 minutes for the action and 30 for consolidation. And I actually use a visual timer to set up my lessons, or I set my alarm on my phone, because the pacing doesn't seem quite comfortable for me even yet. So I have a reminder, and the kids in my classes now know what's going to happen, and they help to remind me as well, just because it's so important that we change the way we teach math. My husband always jokes that he always did a 3-part lesson. It was called taking up last night's homework, watching the teacher do 3 more questions on the board, and then working on tonight's homework. So those were his 3-part lessons, and we don't want to keep repeating that. Ooh, 60 minutes for math. Lucky. Lucky, lucky. So I thought that I would just walk you through a series of questions that I tend to ask myself as I'm planning a lesson, and I'd like you to plan a lesson kind of on your own, whether you share it online or just kind of keep it going through pieces of paper that you're jotting some ideas down. That would make, you know, you get something out of it. You've got a lesson for tomorrow if you want. The first part of the lesson I deal with is the action. And so my first step, or the first question I ask myself is, to what overall expectation will I connect this lesson? I always want to make sure that my lesson connects with one of the overalls. So for the sake of the example, if you're folding, I'm sending you my clothes too, Claudia, sorry, but I chose a grade 6 number sense, and because it was the second overall expectation in the list, that's the operational sense. And I'm not sure that everybody realizes this, but the expectations in the overall, the first one is the quantity, the second is the operational sense, and the third one is the proportional reasoning in grade 6. So they follow the same order of the subheadings of the specific expectations. I always think they should put the label in here. So I've chosen the overall expectation that deals with operational sense. And I put the link to the curriculum document on that slide. It's there in orange. If you click it, do they go there, Louise, right to the site, or does it have to be pasted in the chat for them?
Oops, it would help if I turned my mic on. I'll grab it and paste it in the chat.
Thanks, Louise. So I think if you just go and pick something that you're going to be teaching soon, from Number Sense Numeration, I guess, is the focus, but you could go outside that strand if you wanted to. Yeah, Louise is going to post it in the chat. Sorry, I thought it might be live, but I tried. it's just going to take you to the curriculum document. So if you've got a hard copy, there. Thanks, Louise. So I guess I'll keep with the grade 6 example, Claudia, if you do my folding. Is that the deal? So hopefully you've all had a chance to at least click on the link and start to find your grade and find the number sense, and then just choose which one of the overalls you want to address. And then I'm sure you figured that the next step that I ask myself is, which of the specific expectations will I focus on? So for my example, I chose the solve problems involving multiplication and division of whole numbers. Oh, Claudia had left to come pick up my laundry, I think. So the first thing you pick is your overall expectation. The second thing you pick is your specific expectation. And I always encourage teachers to start every lesson from the curriculum document, because as we know, some of the resources that we buy don't align perfectly with our curriculum, and it can cause problems and misunderstandings. So always start with the curriculum. Overall, then the specifics. At this point, I kind of ask myself, what's my learning goal of the lesson? Because the way the math curriculum is, I could go one of two ways. I could pick the content expectation and address that as my learning goal, or I could focus on one of the processes, and that could be the learning goal that I want to consolidate by the end of the lesson. So I kind of go back and forth here and choose one or both. Oh, sorry. You've caught my attention now. Oh, sorry. Ah, that's what the ding meant.
Sorry. It's probably a bad time to interrupt.
No.
When I clicked on the link, it brought me to the curriculum.
Yeah.
And then when I tried to get back into the chat room, it logged me out.
Oh. Is that going to happen every time, Louise?
It certainly shouldn't be happening at all. Claudia, what did you click back on to get back into the Blackboard? Did you click on the little Blackboard icon, the little purple circle with the little white arrows on it?
On the back arrow.
Okay, so the back arrow, all right, so maybe don't click that one. So if, depending on what computer system you're using, if you have your little running applications along the bottom of your screen, you just want to return to the purple circle, and then your Blackboard interface should pop right back up again.
Okay, I'll try that when I click another link later.
Okay, all right, that's good, thanks.
Awesome. So at this point, I don't really do much with the learning goal. I just start to think about what it might be, kind of having that percolate in my head all the way through. And really, I tend to have one content and one process learning goal in my back pocket, because when you teach through problem solving and you're responding to the ideas that emerge from students, the consolidation you planned may not be possible depending on where the kids take the lesson or the ideas. So usually you can go back to one of the process expectations and consolidate something if the math wasn't really addressed at that point. And again, we'll get to that to later on. Just checking my notes. Oh, the other thing to think about, normally when I'm planning my whole unit, my learning goals early in the unit are going to be more about the content, so the operational sense expectation. And as students build that understanding through lessons that really focus on that part of the math, towards the end of the unit, I kind of refine their thinking or their communication of these ideas by having a process learning goal. So depending on where you are in the unit or the series of lessons, that may dictate which learning goal might be most appropriate. And this takes a lot of practice, and you're going to make as many mistakes as times you get it right, but it's just things to think about, and as you keep doing it more and more often, it becomes more natural, and I think I'm getting it right more often than I'm getting it wrong now, which is a good thing. Next thing I do is I write down any calculation that would have met that expectation. So if a student were to do this calculation or solve a problem that involved this calculation, they would bump against the expectation, or they would have to start to wrestle with these ideas. And I'll just give you a couple minutes. So hopefully you've picked your overall expectation, you have picked your specific expectation, and then write down a math expression or a math sentence that would meet that number range. And hands up or beat me now that I know what that means if this is not making sense to you. A couple minutes to get that written down.
Mary Kay, I see that Barpur has asked if you could perhaps repeat or re-describe that request.
Okay, so the request was just to go back, when you've picked your overall expectation and picked your specific expectation, usually you're given an operation and a number range. So at this point in the planning, I just write down any math expression that meets that description from the specific expectation. So if I scroll back, this specific expectation that I chose said, solve problems involving multiplication and division of whole numbers, and then they give the range of 4-digit by 2-digit. So at this point in my planning, I just write down any math expression that would require students to multiply a 4-digit by a 2-digit. And this just keeps me in the grade range and makes sure I'm going to hit the target. The next thing is I try and think of a situation or a context that is going to be so familiar to the students that they completely understand the context, but it would involve a calculation like the one I just recorded. Because we remember in teaching grade 6 students how to do this multiplication, I wouldn't have taught them the algorithm yet. I don't teach them partial product or any means to calculate this. So I need to embed the calculation in a context that they know very, very well. So when I was thinking of this, I was thinking about an arena and a certain amount of ticket price and what the concert would have collected if a couple thousand people had attended and tickets were a certain price. Now, it needs to be very, very familiar. So I live in Elora, very close to Guelph, where we've got the Guelph Storm. So this is where I went with my problem. Kids know, they go to hockey games, they buy tickets, and at this point, I'd recommend that you actually put a bit of time in, grandfather clock, sorry about that, time in to research and find the exact number. So the last home game for the Guelph Storm, they had 4,343 people attend, and the cheapest ticket is $15. So I put the time in. And you'll notice that my 4-digit number and my 2-digit number have changed since the ones I first wrote down. But I just need a starting point when I'm coming up with a problem. That's why I write the number sentence, and then I change it to tailor it to the exact context that I've created that I know students will be familiar with, because this is how they're going to start to build their understanding of what multiplication is, because I haven't shown them the algorithm and I haven't done any practice like this. The other phrase here that I've added at the bottom, I always add the phrase show your work or justify your thinking. And both of those are the two most common phrases on the EQAO assessment. So while I'm not teaching to the test, I'm definitely having kids practice the same kind of communication skills that's going to serve them well on that test. So I just craft the problem, I make sure it's not too text dense, and I make sure I hit the number range, sorry, for the grade I'm working in. And I think what we do as teachers a lot of time is we knock back the numbers. So if grade 6 is a 4-digit by a 2-digit, sometimes we knock it back a little bit for the grade 6s, and we maybe think that we're warming them up by doing 2-digit by 1-digit and then 3-digit by 1-digit. I don't think I agree with that strategy anymore. I think we hit at the grade range and stick there and then back off for the students we need it. But remember, this is, like somebody said earlier, this is almost diagnostic for the unit when I start my unit this way, and I need to know who is already in the grade range and what I could do to get kids to meet the grade range. But I may not know that if I warm them up with like a 2-digit and 1-digit multiplication first. Any questions or comments? Is it making sense? This is just the problem construction part. It's where it fits in later on that I think is really different, because I think we're all pretty good at making these problems. It's just the structure of the lesson and when they fall in the unit that's a little bit different. So, couple cautions. Students have background knowledge, and sometimes it's their background knowledge that actually gets in the way of the problem. I've got a story. I was teaching with a group of teachers in a classroom the other day, and our problem was there are 3 primary classes in an assembly, and there were 58 students in the assembly. Mr. Green's class of 19 students left, Mr. Brown's class of 19 students left, and Mrs. White's class was left. How many students are in Mrs. White's class? And the kids knew. I mean, Mrs. White was a teacher in the school. The other names are just made up. They knew that there were 18 students in the class. They didn't even attend to the math. They just knew that there were 18 students in the class, even though the answer to the problem was going to be 20. So that's why I say put the time in to do the research, and if there is a real number, use the real number, because somebody in the class is going to know the real number and they're not going to even do any calculating. They just know it. The other problem, and that was done in air quotes, is the real world. And this next slide sums that up. I'll give you a second to read it. No smiley faces? I thought that was funny. Sometimes, oh, there we go. Thanks, Diane. Sometimes we force a real-world context on a problem, and the real-worldness of the problem has to be truly real-world and authentic to the kids if it's going to help them make sense of the problem. When we're teaching through problem-solving, the kids have to have experienced the context of the problem if they're going to make sense of the math that's related. So sometimes cantaloupes are real-world things, but it's not going to help the student understand the multiplication if they haven't actually manipulated the cantaloupe. So sometimes this real-worldness can get in the way of actually helping the students build their conceptual understanding. Oops, sorry. So, I'm going to give you 5 minutes, and more if you need it, and we can ask questions, but actually construct a problem that addresses the expectations that you've chosen. And my warnings there on the slide, pay close attention to the number range in the curriculum. It's pretty clear about which number ranges we're supposed to be working on in the different grades, and it is developmentally appropriate, so be aware of that, and how familiar it is to the students. So if I'm doing grade 1 or 2 math, I'm doing problems about things in the classroom that they see daily. I'm not going much farther than that in the context of my problems because I don't know what experiences they will have. So ask questions in the chat, but we'll take about a 5-minute break-ish for you to actually construct a problem, and then let me know what difficulties you had in coming up with that, and maybe we can help along those lines. So 5 minutes-ish. Thanks. Okay, so I didn't see any problems coming up in the chat. I like the problems that were shared in the chat. nice, they'd have familiarity with the context of the problem. That's really good, definitely on track. So the next thing is, in my thought process, is once I've got the actual problem, I want to think about all the different computational strategies I can think of that a student might use to solve the problem. And the last sentence, see each strategy through to a solution, is really going to help you in the action part of the lesson and definitely help you again in the consolidation. So if I go back to the problem, sorry, I'm just going to scroll quickly to this. Can we come up with different names for the strategies that students might use and just type them in the chat or grab the mic and say it out loud? How could kids solve this problem? Absolutely.
Hopefully not repeated addition.
No, they might not do repeated addition by 15.
But they might group it and then try to come up with a landmark number.
Absolutely.
And then double it, triple it.
Exactly. I could see kids going in groups of 10 and then taking half that again. So 10 groups of 4,343 and then do half. Yep, there we go. Dividing by the 5s and 10s again. Friendly numbers. You could get at it through division. I've got partial products, so they could do multiplication the traditional algorithm that we were always taught, but maybe they would do partial products. So maybe they would do 4,000 times 10 plus 4,000 times 5 and go through it that way.
Yeah.
It's not a horrible thing for them to be doing. So I definitely want to go through all those strategies, as I said, and actually write it down. It won't take long, but it's worth going through all the steps because it puts something in your head that it's going to help. Ooh, expanded notation, absolutely. That'd be a great way. Use their number sense and their place value understanding to do it for sure. Next thing I say is, what are the potential roadblocks? What is going to stop a student from being successful or from at least getting close or making sense of this problem? So can you type that in the chat or again grab the mic and talk about what might be a roadblock for students to solve this problem? Not having a calculator, absolutely. They'd have to have another strategy, right? The large unfriendly numbers, for sure. Right, even if they have the calculator, they might not be able to use it. That's a great point, Maureen. I find that a lot. Yep, place value knowledge. Might be a language issue too, right? I mean, the word minimum was in the problem that I gave. The word box office was in the problem. They may not know that. They may know how to do the multiplication, but just have an error. They might just make a silly little calculation error at that point. By thinking of these roadblocks, sorry, I'm getting feedback. Is everybody else getting feedback too? Is it just me? Okay. Siri is the lucky one. All right. Oh yes, we do like it. I'm happy for Sarah to have a mic on. Oh, for sure. The fact that the remainder, when it's not a whole number, that sometimes paralyzes kids and they start to panic and think it can't be right because there's a leftover. They don't like that. By thinking of the roadblocks, this is what leads me to building my minds on. Because the minds on, the whole purpose of a minds on is to activate the prior knowledge or to get kids thinking about something that might help them solve a problem. So I try to have a minds on that would help students overcome one of the roadblocks. The thing is, I don't want to steal their learning. I don't want to, if this is early in my unit, I don't want to show them how to multiply, or I don't necessarily even want to lead them towards multiplication. If it's early in the unit, my minds on is probably going to make sure that they all understand the context of the problem. And I would do that through turn and talks. My rule is in a 5-minute minds on, I want at least 2 turn and talks. So I would ask one question and then students talk about it to a partner, and then I'd ask another question and they talk about it again. I don't even necessarily take up the questions or the answers to the questions that I ask. I just want kids to be starting to think about the situation. And when I used to do minds on without the turn and talks, I would know that 3 students' minds were on and attending to the problem, but not everybody. So I even put the rule in that both people must talk in a turn and talk. So my rule for a turn and talk is whoever doesn't go first, so somebody starts and answers the question I've asked, and then the second person can add something new, or if they have nothing to add, they paraphrase what was said, so that at the end of my minds on, every student has said at least 2 things that's going to help them get to the problem. Oh, absolutely, Barpur, that's a great point. My minds on is sometimes getting them the manipulatives out and having them do something or make sense. Oh yeah, I'm sure there are lots of great ones, Shannon. And here's the other point. We thought about our learning goal earlier, but I want to make sure that my minds on addresses the learning goal that I'm aiming towards. So here's a problem that I've done with a grade 6 class before. And it's a different one now, but make sense of it. Don't have to start solving it, but if you could just make sense of the problem. Think of you're down on a beach somewhere next week and you need a lemonade to cool down, or a different drink, but lemonade is good too. So this is a context that most grade 6s had some familiarity with, the whole notion of making the juice. And this is a minds on that I gave. These were the turn and talks that the students had. It is another whole problem, Shannon. Sorry, I've kind of switched gears. I've left my other example just to show you how important the minds on can be. So this is one minds on that I gave a class. And this is a different minds on I gave to another class, even when we were solving the same problem. So when I gave the class the minds on, what do you know about 2/5? They brainstormed and told me all they knew. When they solved this problem, it became an activity for them to compare and order fractions, because the minds on that I gave them seemed to prime them towards doing all of this as fractions. So it became 2/5 and 1/5 and 4/12 and 3/8 for the different mixes, and then they just ordered them, which is perfectly fine when my learning goal is for them to compare and order fractions. When I gave them this minds on, what I got was some students used fractions, some used percent, some used benchmark, some used unit rate, and some actually graphed, created ordered pairs for all these recipes, and graphed it. This minds on here was perfect for the learning goal of there is a connections between fractions, decimals, percents, and ratios. So this is how important your minds on is, and how when you're very intentional with the minds on that you choose, you can definitely attack the expectation a little bit more specifically than when it's just a general math warm-up of a game of Around the World or Buzz or something like that. So the Minds On can be very intentional to the learning goal that you're hoping to address. Students still may take it in a different path, and that's okay. You have to be ready for that. But you can be quite intentional when you're choosing your learning goal and choosing your Minds On, sorry, to address that learning goal. So what Minds On could I have asked for my problem? And again, I'm going to flip back. It should be about 5 minutes long. A turn and talk. What might I ask kids as a Minds On for this problem? Imagine it being early in the unit or late in the unit, but just think about the different things you might ask kids to start addressing those hurdles that we talked about and getting them ready to solve this problem. Anybody got an idea? Or maybe if you wrote a problem, you're thinking about the Minds On for your specific problem. If it were early in the unit, I would probably just go along with having them picture themselves going to a big movie theater or something like that and talk to their partner about what it was like when they went to a game, or maybe our school or our class had attended something, just to get the idea that there are a lot of people who have paid tickets. There you go. Absolutely. Be careful that we're not going to a different operation, though. Like, we really want to target. What did we prepare to? Absolutely. Absolutely. How much did we need then for both of us to get in? That's a great question to warm them up. Or I had $40 and I wanted to take myself and 2 friends to the Storm game. Would we have enough? And just have them start to think about that. Those would be great Minds On questions to warm the kids up. So that's Minds On. Not for this problem, I don't think, Judith, but for your other problem, absolutely. And I love this, will there be enough money if there's tax? Because they don't necessarily even have to calculate it. They could just estimate and justify from there. On the sheet, I am not sure where it is, but I have a link that I'll give you before you leave tonight that gives, it's a page I made up for teachers in my board, and I share it with schools I work with, of different things to think about for Minds On. One of my favorites is putting up a multiple choice EQAO question from one of the past years and have them turn and talk to a partner which of the 4 possibilities could not possibly be the right answer. And just get them to start thinking that way, and you can really target and find the exact expectation that you want to address by going through the EQAO index, find the multiplication question and ask them that, which one could it not be. It warms them up and it gets them thinking. Right, Shannon, and that's a problem that a lot of people have. The Minds On tends to get out of control and take up 25 minutes, and all of a sudden you don't have time for your lesson. So I really think 5 minutes, ding, and go on. So it's one question, turn and talk, a second question, turn and talk. I tend to ask the group any questions or anything that should come to the whole class, and then we get straight into the action. And I should say, too, going back, the action, we've planned the problem, but in my classes, it's 2 people with 1 large sheet of paper and 2 markers, and that's how these problems are solved, especially early in the unit. They're always working with a friend to make sense of the problem and solving it on larger paper so we can share for the consolidation. Yeah, they are tricky. Thank you. So if you click on the link that Louise just put in the chat, it's going to take you to a wiki that I've made. It's for grade 8 teachers mainly, although a lot of the support documents that I've put on there are for any grade. So the link that Louise put up is specifically, I believe, going to take you to a 1-pager that has ideas for Minds On. And so, yeah, it's right on the 3-part lesson page. And then if you click on the Minds On, it will take you to some of those ideas. And I think then you're going to get our 1-pager that has just the breakdown on the general 3 parts. And then there's another page on consolidation strategies. And that's where we're going now to talk about the consolidation strategies. I'll just zip back up to my... So the document's called it a 3-part lesson, but I think that was a little bit of a misnomer because it's really a 5-part lesson, but I guess that was too daunting. So they called it a 3-part, but part 3 in my books has 3 more parts. So remember, this is the big bulk of the lesson. This is the last 30 minutes, if not more. If you can get a little bit more time, I think it's well spent at this part of the lesson. Knowing, and this is going to be hard, sometimes you're going to end the action or start the consolidation before all students have got an answer to the problem. And that's a little bit hard to deal with and wrestle with, so you have to build a class climate that that's okay. Students don't panic, and they're okay with that. And we have to get okay with that too as teachers, because it may not be that they needed to get the answer for them to consolidate their learning. It was coming up with a strategy, and especially if they're going off the wrong track, it doesn't really matter if they see it through. But after 15 minutes, whether they're done or not done, we start our consolidation. Yes, I see your arg, Shannon, and I know exactly how you feel, but I do think it helps the kids with their learning. So for the consolidation, if we have 30 minutes, I aim kind of for 10, 10, and 10, breaking it down. And the first 10 is a chance for students to share their work with other students. It's really, really important. And kids, learning is social. So we need to let kids talk to each other about their work and to start making sense of these ideas as a big group. So in terms of sharing, the ministry's got lots of information about gallery walks and band shows and Math Congress, and I can share the links, or you can look up the monographs yourself, and they give some pretty good detailed how-tos for gallery walks and band shows. The thing I would add to a gallery walk is make sure that it's purposeful, because a gallery walk can turn into the poke my neighbor fest or things like that. So I tend to always add a question or a purpose with the gallery walk. So they're walking with sticky notes and they're writing something down very specific to hold them accountable. I see Amy's question, do you start consolidation when some students are finished? I would start my consolidation 15 minutes after the action, or when all students are done, whatever comes first. The students that finish early in the action, I would challenge them to solve it a different way, or maybe have an extension question in my back pocket to give them. Or if they have tried a new strategy, I would ask them the question, does this always work? And usually that's enough to keep the fast finishers, who are the kids that solve the problem quickly, busy for the 15 minutes, but purposefully busy, not just filling time, and gives the others. And Claudia, your other question about the wiki, absolutely share it with anybody who wants to see this wiki. They're welcome to it. It's just my thinking and the thinking of some of my colleagues, so we're not promising it's perfect, and it hopefully will change, and we'll share our new learning as we go, but absolutely, you're welcome to share it with anybody and anybody who wants to read it. So going back to the consolidation, Amy, did that answer your question? Okay. Inside-outside circle is one that I really, really am finding to be effective for this purpose. And if you haven't done an inside-outside circle before, it's talked about a lot in the literacy resources. I know there's a monograph called Grand Conversations, and they talk about inside-outside circle. And in another document that I've shared, I put all the links together, and I'll get it to you later. I'm afraid if I try and get it to you now, I'm going to lose all my screens. There's a one-pager from eWorkshop that helps us set up an inside-outside circle. But I often get kids, so a pair of students is talking to another pair of students about the work, and I just ask them a very simple question. What's the same and what's different about what you recorded on your pieces of paper? And the thinking that comes out of that simple question with this simple organizational structure in the classroom is pretty unbelievable. And it won't be great the first time because we have to give kids a chance to practice this conversation and to get used to talking about their work. But with a little bit of coaching from you and going at it a couple times, it's very, very powerful to get their kids to share their work. And there's some other things that, that we can talk about too to help that along. First thing, you have to build your classroom climate where mistakes are welcome, because that opens up all the doors. Once they're not afraid of being wrong anymore, then the learning can really take off. I'd suggest things like tribes training or a tribes classroom or any other way you can create a respectful classroom. Definitely have posted norms about student-to-student conversation and everything related to that. Again, in that Grand Conversations classroom, in one of the little text boxes off to the side, Grand Conversations in the Primary Classroom is the name of the monograph. There's a text box that has classroom norms, and I have teachers just copying that out and posting it and then revising it through the year. And you have to build a math talk community. So give kids the language to speak about the math. And the first couple times, they won't know what to talk about, but it will get better. And I would suggest early in the year, you invest lots of time to build this community, because we slow down early in the year so we can speed up towards the end of the year. When you've got a group of kids who are learners and can talk to each other and really help each other learn, you fly through content and get so deep in their understanding. So I do think it's time well spent. Here's a picture I took from a classroom in one of the schools I support, and this wasn't work that the teacher made up. This is just copied right out of that monograph that I've titled at the bottom. But this teacher will swear these are the two most important pieces of paper that she's put up in her room for language, and you can see in the title it's about text, but they use it for their math talk too, just how to disagree. Instead of "you're wrong" or "that's stupid," those kind of unproductive words that kids tend to default to, they give them this language, and the thinking, takes off, or the communication of their thought actually takes off. The thinking might have always been there, it was just hidden behind less productive words. Thank you. Yep, there's that monograph right there. Louise was able to post it in the chat. And so this is just copied right out, but I strongly recommend this for classrooms as an anchor chart to just help the thinking go on. Other things that I do, and I said earlier, if when you are, you've made your problem, I suggest strongly that you go through and solve it in as many ways as you can. and that is for this yellow circle here. A tip I've learned in practice is when the students are actually solving the problem, I go around and I circle interesting parts of their work with the yellow marker. Because they want to write with the yellow marker, but nobody can see their work. I use the yellow marker, and students know that what I circle, I'm just going to ask them to talk about it. Really, here are a couple things to keep in mind. When you're circling with the yellow marker, use the asset model of assessment. So really focus on things that the kids have done well. Not focusing on their mistakes, but things that they've done well. For some kids, it might just be the fact that they pulled the important information out of the problem. Or maybe it's a 2 or 3 step problem and they got the first step correct. Or they at least had the correct math sentence or math strategy to attack this. Circle that and give them something to talk about. This is really a trust-building thing for our weaker students. They trust that whatever you have circled in yellow is worthy of them talking about it, and they will be more willing to share their ideas about what was in the yellow circle with everybody. So this has been a big game changer for me to get everybody participating in the sharing part. They're just supposed to talk about what's in the yellow circle. So even if everything outside the yellow circle is wrong, what is inside the circle is worthy of a discussion. And that's been a big thing for me to help everybody participate. The other thing is provide the kids time to rehearse with their partner. If they've solved it with a partner, before you go to the share and have them share with another group of students, give them a chance to rehearse. What are you going to say about what's in the yellow circle? I don't know, maybe you've had this where you've got a kid or you bring the group up and you ask them to share their work and they start with, well, first we got the orange marker, then we wrote our names on the paper, and they can't really get into the math quickly because they don't know what it means to share their work. So give them time to rehearse and focus. And if you've got those anchor charts, they'll have the language to start to use to explain their thinking and everything like that. So help them find the important math by circling it with the yellow marker and give them time to rehearse. And the sharing part of your consolidation will be a lot more purposeful and directed to your learning goals. And I should go back. The reason you've done all those sample calculations is you will have those numbers in your head. So when you're going around with your yellow marker, you'll know what's on track quickly because you will recognize it from the work you have already done. But it's pretty surprising. Kids will still surprise you and come up with, as somebody already said in the chat, they will come up with strategies that you have not considered. And then when you think that you've got them all this year and you do a similar problem next year, you'll still get new strategies. So it's pretty wild. The next part, so that was 10 minutes of them sharing. Usually inside-outside circle. Sometimes I direct them to who they are going to share with. Usually it's just twice. So one pair of students meets with another pair, and that's about 4 minutes, and then they switch and they share with one other pair. So not everybody has shared with everyone, but that's probably not really that important every day. And then they put their work up on the board, and this is my 10 minutes to highlight the learning goal. So this is where I can go a little bit teachery. I can annotate the student work and bring out any of the math that I really like. If somebody solved the multiplication problem that I was talking about with the algorithm, I might label it algorithm. If somebody used repeated addition, I would label that strategy as repeated addition. So like we build their language by labeling it after they've done their learning. In language, I would do the same in math. Name the strategies, talk about the differences or the similarities that existed, maybe even highlight them in the order of sophistication, possibly. Start with repeated addition, then repeated addition with some grouping, then maybe partial product multiplication, and then towards a more traditional algorithm. I might sequencing my highlighting in that way, but maybe not necessarily. And this is where I specifically state my learning goal. So maybe my learning goal for my product, my problem that I wrote, is that when you multiply two whole numbers, you get an answer that is bigger than either of the first numbers. That might be my learning goal. Or it might be when you multiply two whole numbers, you always get a whole number product. That could also be my learning goal for that. And it's at this time in the lesson that I actually say it. I also, as I'm highlighting, this is when I might build my anchor chart. So my anchor chart might be about the content. It might be the connection between a partial product calculation and the traditional algorithm, and show students how they are the same. It might be where I build vocabulary and add it to our math vocabulary bulletin board or something like that if I have that going on in the class. But this is where I would do that sort of work in the lesson. I've taken it from the student learning. There's evidence of it in their work that they did during the action, and now I label it and highlight it and kind of formalize it or help them generalize that learning. And the point, build the anchor chart, but link it directly to student work. That's a big thing. So if I make a point maybe about just the multiplication algorithm, I would then have a ribbon, and maybe Bob and Jane did the algorithm. I would put their work right beside my anchor chart with a ribbon that links their work to the concept I'm including on the anchor chart, so that the work on the walls is theirs and it's purposeful and it will help them with their learning. It's a good time now to construct the success criteria. And I find in math the success criteria tends to be best connected to the processes, because it's that critical thinking piece of, am I done, or is my work of high quality? And there's really no high quality aspect to the actual calculation. It's probably right or wrong. But there might be some quality to how I've communicated my thinking, or have I justified or reflected, or things like that. So in this highlighting part of the lesson, this is when I would co-construct with my students the success criteria. Not for the whole unit, and maybe I'm just adding one more idea to my communication, like how to communicate multiplication. I could add that part to my success criteria for communication. So just going on that way. Any questions about the highlighting? As I said to some teachers, this is what you do, or when you do what you used to do at the front of the lesson, where you would do the teachery part of it and kind of highlight all the skills. This is where it now fits in after they've had a chance to wrestle with the concept through the action, and then sharing with their friends and getting their friends thinking. This is where it's now going to maybe make sense conceptually to them. And they're not just going to remember the procedure or the steps, or because what happens is some kids with a strong working memory remember our procedures, and if a student has a weak working memory, they don't remember and they didn't make sense of the math concept. They can't remember the procedure, and I think that's what has led us to develop a society that's quite math anxious. So anything we can do to get away from that. My biggest problem is trying to read the messy writing on the chart papers. Judith, I agree. So when you get to this point, Judith, if you have a lesson where it's a messy, messy day, my next lesson is, the action is to, my mind's on might be reminding them about clear communication, and their action is to take the work from yesterday, which was the very messy day, and re-record it on paper so that the thinking is more clear. I don't go and clean that up for them. They need to know how to make sense of that. So that might be your action the next day. Is I heard lots of great math ideas yesterday, but when I looked over the pieces of paper, I could not make sense of them. I need you to rewrite this so that it's more clearly communicated. That helps them a lot, and it starts to build good skills. Yeah, and other things too, like sometimes the problem, this is what I do. If I see a problem in their work, that becomes a problem the next day. Or maybe I want them to get to the multiplication algorithm and nobody's even getting close. They're staying at repeated addition. I might throw down the next day, not day one where they're making sense of it, but maybe day 2, I give them the algorithm and I ask them to make sense of it with what they did yesterday. So if they always do repeated addition, they'll start to see some of the same numbers in the algorithm and start to make sense of it. So, or I give them a problem with an error in it, and they have to find the error. Or just like you said, the messy writing, they fix it and recommunicate it in a more clear way. So that's the highlighting part. And then the last part is the practice. And it tends to be called independent practice, but really this is your assessment for learning time. This is where you're going to get all the information in terms of the pacing and what you're going to do the next day. So for students that you're fairly confident are ready to do it independently, I would say they do something independently. But for those kids that you know they don't have the concept yet, they're not ready, this is a perfect 10 minutes to pull a little guided group and maybe go through the same problem from today through a think aloud where you lead them through it one more time. Don't rescue them during the action. Let them still be muddling at that point. But towards the end of the lesson now, the last 10 minutes, you can pull a guided math group together and go over the ideas from today's lesson or make sure they understand the anchor chart you just created or things like that. In terms of what the practice could be, sometimes I just change the numbers. So they have the exact same problem with the exact same context and I just change the numbers. That's a really simple way. Sometimes it's just calculations. So maybe given if I gave them the storm problem, the practice might be I would write down 5 other multiplication questions that involve 4-digit by 2-digit multiplication. And I always like to build in choice. So I get kids to do 3 of the 5. They get some choice in the ones that they're not going to do. You get a lot of assessment information based on what they don't do. So if you do some 2-digit numbers under 20 and they all choose those to multiply, but they don't do the 67s and things like that, that gives you a lot of assessment information in terms of they like the smaller numbers, they're a little bit worried about those large numbers. It lets you know where to go the next day. At the end of the practice, this isn't practice that you then correct and put in your mark book. This is practice because when you quickly go through, I just sort their practice into 2 piles, those that met my expectations and those that didn't. And then I use those piles to create my pairings for tomorrow's action. So I might pair somebody who got it with somebody that didn't. Or I might pair somebody that got the math but couldn't communicate it clearly, and I might pair them with somebody who had the opposite skills to try and build this. Oh, Claudia, you challenged the students to actually write new problems? I think that's a great practice. That's awesome. You get to know a lot about whether the kids totally understand it if they can put it into a context on themselves. I bet they get stuck because that's conceptual. And maybe the Kumon is more about the procedural fluency, which is a really important part of math, but it is not the only thing. We have to get for the adaptive reasoning so that kids know one thing and apply it in a slightly different context, or just have the concepts that they can share to other ideas. Other things to look for in the practice: do you need parallel tasks tomorrow? So do you need 2 problems that students are going to solve simultaneously, one that has one set of roadblock and a different one that has another roadblock for the kids, and they can choose which one they're going to address. And sometimes our independent practice tells us that the kids don't need to spend too much time on this because they all get it. And so I would check in a couple of days later to make sure they really do get it. But when students get the independent practice, that tells you you can probably move on. And don't be fooled, because a lot of times I find that the action makes it look like everybody got the math, and then when it comes time to independent practice, sometimes 2/3 of the kids don't have it. So the fact that they were working together made them more successful. It's not even a 50-50 for the independent practice. There's more than half of the kids that don't get it. So we want to be careful about that. A couple other things. So once you've, I agree, Maureen, the closing gap materials are really good, and about the parallel and open tasks. Marion Small wrote Closing the Gap, and she also has that book about DI, math, and good questions, asking good questions in math, and she's done a lot of thinking about parallel tasks and open tasks. Very good for practice. Yep, she's definitely connected to the EduGain site as well. A neat thing is once you've got one problem written, you've got 2 more problems for the next 2 lessons. And this is something that I think as teachers we need to think a lot more about. There are 3 kinds of problem structures. Actually, there's 4 because there's a compare one. But I gave the problem I gave was a result unknown question. But the students need to think about the same problem as a start unknown and a change unknown question. So I would change the numbers slightly and go on to all these other problem structures. Our kids tend to know result unknown questions because that's what they work with most commonly. But these other kinds of question and problem structures are unfamiliar to students. I was in a grade 1 class the other day, and out of the effective guides, I pulled the question that said, there are 7 students in the classroom. They are all at either the art center or the sand table. If there are 5 students at the art center, how many are at the sand table? So 7 kids in the room, 5 are in one place, how many are at the other place? And they argued with me that it was 12. Because they don't understand these different problem structures, and they knew it was an adding question, and they just took the 2 numbers from the problem, which probably a well-intentioned teacher at some point told them, you take the problem, you take the numbers, and you look for keywords of all together or something like that, which tells you add, and they added 7 and 5, and they got 12, and they were quite adamant that it was 12, and even when we acted it out with 7 kids, and we put 7 kids at the art center and had 2 more and moved them towards, they still told me 12. So I think we need to do a better job of all these different problem structures, and a good spot to get some ideas about them is in the effective guides, volume 5, and I can definitely share that link. If I disappear, it's because I don't know how to get back. But copy. Yeah, I'm back. That link that I just posted in the chat will take you to volume 5 of the effective guides, which is teaching basic computations. They have a really good section in there on the problem structures. And it helps you start to make sense that once you have one problem, you really have 3 because you can just change the unknown and have kids wrestle with that. This is how kids start to see the connection between addition and subtraction, because every result unknown addition question is a start unknown subtraction question, and it goes back and forth like that, and it builds the connection between multiplication and division. I think in Vanderwall's books, he says never teach subtraction and never teach division. Just always kind of teach addition, and then subtraction is a variation of an addition question, and division is a variation of a multiplication question. So neat ideas from him. The other link I wanted to share, now that I know this is going to go well, you've got the wiki. This that I can share now should take you to a Google Doc that I've created that kind of just summarizes this whole slideshow in terms of the thought process I go through for planning a 3-part problem-solving lesson. And the three-part lesson is just one way to address problem-solving. If you are teaching through problem-solving not in the formal three-part lesson, I think that's fine. I just really appreciate the structure of this three-part lesson because it keeps me focused and moving along and keeps the kids going too. So I got 4 minutes to spare. So questions now? Or if you want to jot down my email, and there is also the link or the address, I guess it's not working as a link, to the wiki that I created. Oh, thanks, Maureen. I knew it was World Math Day. That's why my husband made pie for dinner. Arg. Oh, there's a question.
Okay, it's from me, from Claudia. So I saw that, or I heard you say that on day one, you want to give them a question that lets them make sense of the expectation that you're presenting to them. So that would be like day one, where they're kind of figuring out, your basic question, they're making sense of it, and then somewhere down the road, you're getting to a point where you're checking in to see for understanding. In between day one and that final check-in day, is there some kind of a list or some kind of a title for those days in between where you're building on your questions so that you know that you're actually working through a progression of questions and not just kind of asking the same types of questions over and over?
I would make sure I've hit all three problem structure types before I worry about that too much. And kids will help and learn on the way forward. I guess I would build in other types of three-part lessons, maybe like the one I talked about where they just have to refine the communication. I've given them the answers and they go back. I think I'd really rely on the effective guides and their progressions for developing concepts and make sure I address those. But I'm not sure that that's exactly what you're asking me.
Well, I just find that a lot of times within the first few days of presenting it, presenting the expectation, they kind of understand it. I feel that they do, and then when I check in and I have them do an individual problem, and most of them get it, then I think, well, maybe I've made it too easy, or maybe this is how do I build onto my original question? So, for example, if you take your Guelph Storm question, what would be your question tomorrow to build on it? Would it be the same type of question, or would you just interchange those numbers?
The day after, I would probably say something like, everybody paid $15 and the storm made $73,900 and whatever dollars. How many people must have attended that game? It's still a multiplication question that they can address through division, or it's a division question that they can address through multiplication. So that's going through the different problem structure. That would be a start unknown question, where I just kind of work back and forth. I would also then take it to the other, like area, right? If you're doing multiplication, you should be doing area problems simultaneously. So I would make sure they could apply it in the other strands of the curriculum where it makes sense.
Okay, or perhaps in the activating part of it, you would do a start unknown with your question from yesterday, and then give them a new start unknown question.
Absolutely. Makes perfect sense to me. I also give a lot of questions where I leave the number spots blank and the kids fill it in themselves. Or I give them number ranges.
Okay.
And that helps the kids really differentiate. And that forces some kids into ugly numbers, and then they deal with how they get back to friendly numbers, which is a lot of thinking. And it gives me a lot of assessment data in terms of what the numbers that the students are choosing. If they're choosing 1,010, I understand that they know about multiples of 10, but I want to push them to other numbers. I mean, but ask that model of assessment, that is something good for me to know. This is comfortable for them to work in multiples of 10.
Mm-hmm.
The
Okay,
world
great.
just doesn't have that. Yeah. Thanks, Claudia.
Thank you. That's great.
Anybody else that I can help or answer, clarify? It's a lot of me talking. Sorry about that. It seems all quiet now, Louise.
It sure does. Okay, well, I'm going to thank everyone for your participation tonight and thank Mary Kay as well. Very, very detailed information about structuring all these kind of math problems to get the kids thinking and problem solving through thinking and vice versa. It is kind of a flowing web of math thought in a way. I'm just going to halt the recording now, actually. Wait a minute. No, I won't. I'll advance to the last slide first. If everyone could click on the tiny URL that is right there on the screen, that is our feedback form, and I've also put the link into the chat, and it only takes 1 or 2 minutes to fill that out. We do appreciate your feedback a great deal. It helps shape future programming.